Hello, I'm Paul Beckwith, and this is Shackleton the Explorer. He's a bit fussy right now just because it's feeding time. It's hungry. He's very hungry. It's early in the morning. I don't usually film videos early in the morning, so if I seem kind of incoherent or tired, that's the reason why. I normally film late at night, but I'm trying something different because I've got such a full day. And this guy is not used to making his appearance in the morning either, of course. So in this video, I'm going to talk about two main things. I'm going to talk about how the Earth's albedo from between 1998 to 2017 has been measured from the Earthshine. So what Earthshine is when you look at the moon, if you see a crescent, the very bright part of the crescent is reflection of sunlight. So it's from the sun to the reflecting light off the moon back to your eye, and you see it very bright. And you can also see the dark part, the part that's outside the crescent, and that is actually called Earthshine. So it's light from the sun that reflects off the Earth, then goes to the moon and hits the moon, and that's the part, and then reflects back to your eye, and that's the part that you see the Earthshine. So we can measure the overall albedo of the Earth from this data. So I'll be talking about that primarily, but I'm also talking about a GoFundMe site has been set up to help support me going to COP26 in Scotland. I leave in a couple weeks, less than a couple weeks, and I'll be presenting, giving press conferences just about every single day, sometimes multiple press conferences in a day on all kinds of different topics, and I'll show you some of the details of what topics I'm going to discuss, and please suggest some if I'm overlooking some. But in terms of the Earthshine, okay, what's been determined is extremely significant. So the overall reflectivity of the Earth, or albedo, is about 30%. So you have incoming sunlight on the Earth, overall averaged over the whole Earth and over time, the reflectivity or albedo is about 30%. That number has been seen to decline by 0.5%. So instead of 30%, 29.5%. And this is over the last 20 years or so, with most of the decline happening in the last few years. So this is very, very significant because a dimmer Earth, an Earth that doesn't reflect as much sunlight, is absorbing more sunlight, and that's of course contributing to significant heating. It's adding to the heating. The 0.5% reflectivity decline doesn't seem like a big difference. But it is, and I've reported that the Arctic, the overall reflectivity of the Arctic, has declined from 52% to 48% in the last few decades, and that's measured by the Ceres satellite sensors. So that decline of 0.5% represents an increased warming absorption of 0.5 watts per meter squared. So I want to put that number in context. The radiative forcing of the Earth between 1950 and 1750 was 0.57 watts per square meter. Between 1980 and 1750, that number is higher, of course, 1.25 watts per square meter. 2011 to 1750, that number is even higher, 2.29 watts per square meter. And from the most recent AR6, Assessment Report 6 from the IPCC, that big, huge report that was just released a few months ago. So if you compare 2019 versus the year 1750, the radiative forcing, the total is 2.72 watts per square meter. And that's caused a temperature rise, according to this assessment report, of 1.27 degrees Celsius. So 2.72 watts per square meter, causing a temperature rise of 1.27 degrees Celsius. So the ratio there is about, it's close to a half, right? 1.27 degrees Celsius versus 2.72, it's about a half. Or you divide by 2.142 if you calculate it precisely. Now, and again, that's with respect to 1750, and that's right in the IPCC reports. So what's happened is the reason for this reflectivity drop is believed to be the higher ocean temperatures with less clouds, less low-level clouds. Low-level clouds cause a cooling of the Earth because they reflect away the sunlight and cause the shading underneath and cause a slight cooling. So the fewer clouds means that there's more solar energy hitting the surface of the Earth, more heating, and that change is 0.5 watts per meter squared according to this Earthshine data. So anyway, if you add 0.5 watts per square meter to the 2.72 watt per square meter forcing number, you get 3.22 watts per square meter. Okay, and that represents a temperature rise using the same scaling factor of 1.52 degrees Celsius. So from these numbers, we're basically already past the 1.5 degrees Celsius temperature guard band, which everybody at the COP26 in Glasgow will be talking about trying to keep within, and we've already exceeded it. And this is hugely significant, of course. And now I'm going to talk about the details and how I arrive at those numbers. But the key thing is the Earth is darker than it was just a few years ago. It's not reflecting as much sunlight, so more sunlight is being absorbed on the surface, contributing and to abrupt climate change, making the warming much, much faster. Okay, so my cat's driving me crazy. Okay, so I'm going to show you all of the details, or at least the key points. I hope the volume is better. I'm trying some different things here. One of the problems, I think, is on my iPhone. I would have the volume turned up, the volume setting turned up to max, and then do my filming, but I'm doing it. It's halfway. I don't think it should be max. I think that's probably contributing to my problem with low volume. Excuse me, because I have a new microphone, a Yeti, and which I will be bringing to the COP. Okay, so I'll get to this paper, but first of all, I just want to, on Twitter, I just posted this 17 hours ago. I've got my plane ticket, Airbnb. I'm prepping like crazy. So this is a GoFundMe to help support me going to the COP and giving presentations to the world and leaders, etc., on all of the stuff that you've been learning from me from my videos. So I want to thank Heidi for setting this up, for organizing this fundraiser on my behalf. This is me, and I will wear a suit and tie and look all spiffy, and got to go get my hair cut maybe later today. So I've got a lot to do before I leave for this conference. So this is, this is a blurb about me and the conference. It's a COP26, Conference of Parties 26. United Nations Framework Convention on Climate Change. The key thing about all my costs and travel expenses and all my work for these videos is I'm not being funded by any government sources, by any sources except for my donors like you, my listeners, and that this allows me to maintain complete scientific independence and just say things exactly as I see them to the best of my knowledge and ability. So hopefully my videos are entertaining and comprehensible. And they pertain usually to climate system science, abrupt climate change, meteorology, oceanography, and earth sciences. I occasionally teach as part-time professor at U of O. I've taught many courses there. Not much since COVID started. The funny, when I'm teaching at the university, I want to do in-person courses. So hopefully I can start that up soon. Of course, this is a photograph of me from the COP25 in Madrid. And I've been on lots of radio and podcast programs, etc., etc. So what I'll be doing is, at COP26, I'll be in many panel discussions, providing climate reports and reporting on CO2 levels in the conference. I have a CO2 detector which I'm bringing, and I've been playing with it at home and in the car and getting lots of interesting data on it. I'll be meeting Peter Wadhams and Stephen Salter and Dr. Yi Tao, many youth activists, etc., etc. So I'll be recording videos every day. These will be at UN press conferences. These will be recorded by them on their system, but I will also record it separately so I can upload the talk each day. These are 27-minute talks, so I can do it all in one go, because I've extended my YouTube ability to do longer YouTube videos. So these are some of the topics. Now, if I'm missing some, please let me know, but carbon dioxide drawdown via ocean pasture restoration, water, crumbling coastlines, storm surges, massive flooding, wildfires, feedbacks, the jet streams, everything you need to know about climate changing jet streams. And the jet streams are changing, and they're slowing. They're getting wavier, and they're changing location as the Arctic is warming like crazy, and this is causing increases in the frequency, severity, and duration of extreme weather events around the planet, like torrential rains leading to floods and droughts in other places. So that's a key part to understanding weather patterns and systems, extreme weather events. Weather wilding, weirding, whiplashing, why it occurs, how the meme of money is fueling planetary destruction, the oceans, the heating, stratification, acidification, deoxygenation, the likelihood for global food shortages and famine within 1 decade. And I think this risk is getting larger and larger all the time. Cascading feedbacks, migration of people, animals, and yes, plants, education, understanding exponential growth. People just don't understand exponential growth and the risks from it. Fossil fuel subsidized destruction. The fossil fuel subsidies are just out of control. They're unbelievable. They're much larger. All that money in the recovery from COVID that's gone into fossil fuel subsidies, that's a crime. Heat waves and drought creating uninhabitable regions, that's happening already. Global dimming. Scientists yell from rooftops. Politicians go blah, 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 or blah, blah, blah. I changed it from Greta's blah, blah, blah to blah, 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 or maybe that's just a typo. Marine cloud brightening, human health decline, spiking climate change mortality, and climate restoration, what we need to do. Okay, so I'll be talking about all of these things, and they'll all be recorded. I'll be bringing you the videos. But let's go now to the Earth's albedo being measured from Earthshine. So first of all, this is Earthshine. So this is sunshine. The sun is shining. It's reflecting off of the moon, and we're seeing it on Earth. So that light is coming to our eye. This part here is actually not getting direct sunlight on it. This is in darkness. The sun is not hitting this. The sun is hitting the Earth. Some of the light from the Earth, that reflected Earth, light from the Earth, that 30% or so, is coming and hitting the moon and reflecting back to our eyes, so we see this. So this is called the Earthshine, okay? So that's a key factor. It's being measured from an observatory in Big Bear Lake, California, which is here roughly in California. Okay, it's mostly a solar observatory. I talked about the radiative forcing. Okay, so this is what I can find just by going to Google Images Radiative Forcing 2021, but it doesn't have the latest IPCC AR6, so I go into the AR6 report on the IPCC website, and this is the Chapter 7. This is diagram figure 7.6 and 7.7 I want to point you to. I wish they'd get rid of this. This is ridiculous. Mess, you know, this anyway. Okay, so this is the change in effective radiative forcing from 1750 to 2019 in watts per square meter, and it has the components CO2, methane, nitrous oxide, and halogens, ozone. This is land use changes, and the aerosols are causing some dimming and blocking, but if you get the total anthropogenic, it's 2.72 with the error bar here, so it's between 1.96 to 3.48, quite a bit of error spread, but 2.72 watts per square meter. So the Earth dimming, becoming darker, having a radiative forcing because of more absorbed sunlight of 0.5, look how 0.5 on this scale is. It's huge compared to these other effects. And if that adds 0.5 to 2.72, then we would have 3.22 watts per square meter. Okay, so how does that translate to temperature? Well, this is the temperature contributions from all of these different components, okay? So the scale here is in watts per square meter. The scale here is in temperature. The key thing is that we've got, 1.27 degrees Celsius increase in temperature in 2019 relative to 1750. There you go. There's that number. And the aerosols are offsetting about half a degree Celsius or so. Okay, well, we've got another half a degree Celsius, anyway. So if I take the scale factor of this number, 2.72, to this number, 1.27, and then add 0.5 watts per square meter to this for the global dimming effect, the Earthshine effect, the lack of clouds effect, then you get a number of 1.52 degrees Celsius, okay? So anyway, these numbers show that this effect, this Earthshine effect, this effect that's been measured from reduced clouds over the ocean as recorded in the Earthshine is enormous, and you can match it to the series data as well. So this is a little bit about Big Bear Solar Observatory, the main dome at Big Bear Lake. And this is a smaller dome here. So this is where solar measurements are made. Measurements are made of the sun, during the daylight. They've got all kinds of instruments. It's a solar observatory. This little guy here is where they do the Earthshine measurements. Okay, a little bit about Earthlight. You can Google it to get more information. This is their website from the Big Bear Solar Observatory. They have all kinds of stuff on watching the sun, etc. But this is their site on the Earthshine measurement. So measuring Earth's global albedo or reflectance is a critical component of the global climate. Okay, and so on. So here's the Earthshine dome here, and here's the solar observatory here. And basically what you see is, now it depends if the moon is waxing or waning. So if the moon is like this is the crescent here, okay, and this is growing, so we call this waxing. And here, this is the dark area, this is the light area, this is waning, okay, then this is a location looking straight down on the Earth and on the Earth here and the moon here. Sunlight's coming in. You basically are sampling the light's being reflected from different parts of the Earth. So these two measurements here, when the moon's waxing, when the moon's waving, we can get reflectance from about 80% of the Earth. So we use a second observatory in Tenerife, I believe, an island, to get to full 100% coverage of the Earth. And this is some data showing the observations. This is a part of the moon and where the measurements are made. And there's lots of details on the actual data, but I want to get back to the paper and show you the key result. So the key result is the reflectance of the Earth is a fundamental climate parameter. It's actually been measured using Earthshine, and there's a gradual but climatologically significant 0.5 watts per meter squared decline in the global albedo over the 2 decades of data. That's a decline of 0.5%. So a nominal 30% albedo for the whole Earth becomes 29.5. Most of the change is just in the last few years, and series measures different regions of the Earth and saw a decline also. It was about twice that of the Earthshine. Okay, so this is significant. So in this paper, let's go to the data. So this is the, depending on the lunar phase angle, we can get an apparent albedo of the Earth, and then we convert that to the an overall average albedo number. Some equations here. You can see different trends in the albedo over the years, you can we'll go to this graph here. This is the key thing. So this is the Earthshine annual mean albedo anomalies from 1998 to 2017 in watts per square meter. So what you see here, we've got the series measurements. Okay, the series measurements are in blue, and the Earthshine measurements are in black. And what you see is a decline. You've got 0.3 down to minus 0.2. You've got a decline of 0.5 watts per square meter of reflected light from the Earth. So the Earth is darker. That translates to 0.5% albedo change. And the series measurement shows even more decline, but it doesn't sample the whole Earth. It samples a smaller region of the Earth, the way the satellite sensors are set up. So this is a key result. The Earth is getting darker. Therefore, it's absorbing more solar radiation. It's not reflecting as much away. And it's believed to be due to fewer clouds over the ocean. Okay, so this is a hugely significant result, and I will be talking about it at the conference. So please, if you are able to, please help me out. Like I say, this is completely self-funded, all my endeavors, and so I've got lots to say at this conference. So thank you for listening, and thank you for all your support, and watching my videos, sharing my videos, and my next few videos will be on jet streams, I believe. It's in the schedule. Okay, well, thanks again, and bye for now.